All right, let's get into it. Today, we're putting on our detective hats to investigate one of the most frustrating mysteries of modern life, the case of the slow internet.
You know the feeling, right? You're paying good money for that high-speed, fast lane, but somehow your connection feels like it's stuck in the middle of a digital traffic jam. So what is really going on here?
You've done all the usual stuff. You did the classic turn it off and on again. You've shuffled closer to the router. But that movie is still buffering, your game is still lagging. All the evidence suggests the problem isn't actually coming from inside your house. Which brings us to our prime suspect, your internet service provider, your ISP. And the charge? It's a practice known as throttling. So what is it exactly? Well, the key word here is deliberate. Throttling isn't some accident or a random technical glitch. It is the intentional slowing of your connection by your ISP, usually to manage the flow of data across their entire network.
And here's the sneaky part. It's not always a blanket slowdown. It can be super specific. Your regular web browsing might feel totally fine, but the second you fire up a streaming service or start a big download, bam, everything grinds to a halt. That's because those activities use a ton of data, which makes them a prime target.
But how do they even know what you're doing? Well, they have a really powerful tool called Deep Packet Inspection, or DPI. The easiest way to think about it is like this. A normal network check just reads the address on an envelope. DPI, though. DPI opens the envelope and reads the letter inside. It lets your ISP see the actual content of your data.
And hey, don't just take my word for it. The security experts at Fortinet describe it as a way to examine what's inside your data packets as they move through the network. This little bit of tech is the key that unlocks that very selective, activity-based throttling.
All right, so now we have to ask the classic detective question, why would they do it? What's the motive for an ISP to slow down a paying customer?
Well, there are a few big ones. The most common explanation is just managing network congestion. You can think of it like rush hour on the highway. Another one is pretty direct. You hit your monthly data cap. But then you get into the more, let's say, controversial reasons, like selling more subscriptions than their network can actually handle, or creating paid fast LANs for companies who are willing to pay extra for priority.
Now, here's where it gets really interesting, because there's a technical reason you might get throttled through absolutely no fault of your own. See, back in the old days of the internet, every house had its own unique public IP address. But we started running out of those addresses, so now a lot of ISPs use something called carrier-grade NAT. And with this, thousands of different homes can all share a single IP address.
And this is a huge problem, because if just one person sharing your IP address does something sketchy, automated security systems might flag that entire IP and throttle or even block it. It's a case of digital mistaken identity, where you and hundreds of your digital neighbors get punished for one person's actions.
And this isn't just a hypothetical. Research from Cloudflare found that internet traffic coming from these shared CGNAT addresses is a whopping 3 times more likely to get rate limited or throttled. That's a massive difference, and it creates this sort of invisible penalty for a huge chunk of the internet.
This whole debate really gets to the heart of a huge principle called net neutrality. The core idea is simple. All data on the internet should be treated equally. Your email from your grandma shouldn't be slower than a video from some huge streaming service that paid your ISP extra for priority.
In the US, this has been a legal seesaw for years. Back in 2018, net neutrality rules were overturned. But just recently, in April of 2024, the FCC voted to bring them back. This is a constant, ongoing battle over who really gets to control the speed of the internet.
So, with all that in mind, how can you figure out if you're a victim in this story? Well, it's time to find the evidence, your digital smoking gun.
The method is actually surprisingly simple, and it uses a tool called a VPN, or Virtual Private Network. Here's what you do. First, run a normal internet speed test. Then, turn on your VPN and run the very same test again, from the same server if you can. Finally, just compare the two numbers.
Now, if your connection is being throttled, the results can be pretty dramatic. You might see a download speed that's way higher when the VPN is active. This right here is the clearest piece of evidence you can possibly find. So, what's the trick? Why does this test work? Well, a VPN creates a secure, encrypted tunnel for your data. Your ISP can still see that you're connected to the internet, but thanks to that strong encryption, it can't use deep packet inspection to see what you're doing. And if it can't tell that you're streaming or gaming, it can't single out your traffic for that targeted slowdown.
Okay,
Let's say your investigation turns up hard evidence of throttling. The case isn't closed just yet. The next questions are, what can you actually do about it? And what does the future of all this look like? You definitely have some options. For starters, keep a close eye on your data usage to see if you're hitting a data cap. Using a VPN regularly can, of course, help prevent that activity-based throttling. You can also make your voice heard with regulators on the issue of net neutrality. And if all else fails, you can always vote with your wallet and switch to a provider that has a no data cap policy, if one is available.
Looking ahead, new technologies like 5G network slicing are really changing the game. This tech lets network operators create multiple dedicated virtual slices of their network, with each one optimized for a specific task, like one slice for super low latency gaming, another for high bandwidth video. It's a much smarter way to manage traffic.
And this brings us right to our final lingering question. As our networks get smarter and more sophisticated, will the kind of crude throttling we see today just become a thing of the past? Or will this kind of network management just get better at hiding in plain sight? That's a case that still remains to be solved.